So today we're going to be doing gas station. The question is, there are n gas stations along a circular route where the amount of gas at the ith gas station is gas of I. You have a car with an unlimited gas tank and it cost of I of gas to travel from the ith station to the next ith plus 1 station. You begin the journey with an empty gas tank at one of the gas stations. Given the two integer arrays gas and cost, return the starting gas station's index if you can travel around the circuit once in the clockwise direction, otherwise -1. So we have an example here. We have the amount of gas we can get from each gas station at the ith index, and then the cost of getting that amount of gas. And we want to find the index that would allow us to loop through the list, ensuring we meet the constraints that we have sufficient gas to make that journey. So let's start by looking at this first example here. So we have this list for the gas we can get at each gas station, and we have this next list for the cost to get that gas. And the important thing here is that this cost, we have to ensure that to travel to the next gas station, we have to ensure that the gas it takes us to go to the next station is possible. So one thing we can clearly see is that, for example, if we started at gas station number 1, which would be the 0th index, we could at most get 1 unit of gas. However, it would cost us 3 units of gas to get to the next gas station. So that would be impossible. So we can note that to see if we can go from one gas station to the next, we must subtract these two arrays the same way we did the first index, 1 minus 3. If we can do that for the remaining indices, we can get a better understanding of which gas stations are beneficial to start at, so we can go to the next gas station. So if we do this here, we get -2, -2, -2, 3, and 3. So another thing we can note here is that suppose the sum of this difference list was negative. If the difference was less than 0, that would imply that there is no possible way to travel all the way around the circular route because there isn't enough gas in the route to make that journey possible. So this would be impossible. So that would be an easy way to get this return statement here, to figure out if it's even possible to go in the circular route. And then after that, once we know that it is possible, we would have to find the start index. And I believe we can just do this by starting at a positive number and seeing if we go around a loop starting at that number, can we get to that same index. So if we start at this index here, which is number 3, and we go around a loop, ensuring we subtract all the differences when we get to that index, can we still reach this index here? If we can reach this index, then it is possible. So loop through the difference list to find start index. And so if we do these two things, we should in theory get the correct starting index. So let's implement the solution. So we need a difference list. So we can create that diff is equal to list a minus b for a comma b in zip of gas, and then cost So we're just subtracting gas and cost and finding the difference list here. And we can see if the sum of the differences is less than 0, we can return -1, as we proved here. Otherwise, in theory, it is possible to reach all the way around. So we just have to find the starting index. And again, to do that, we just loop through the list to see which path would allow us to ensure we never get a negative cumulative sum within the list. So let's do that. So we need a few things. Let's jot down n, which would be the size of the route. So that's this. Next, we need a start index. Oops. Let's start that as 0. And we also would need to return the start index. Otherwise, we need a current index and a current cost. So the current index would be, we could say start index +1, and then we would need to ensure it's within the route. If the route is only one gas station, we need to modulo this by n. And then the current cost would just be, I think it would just be difference of the start index. Now we start to loop through the list to see if it's even possible to create to go all the way around. And if it's impossible, we reset the start index to a better value. So while start index is not equal to current index, we first need to ensure if current cost is less than 0. We have to reset a few things. We would first need to reset the start index. So start index would need to now be current index, I believe. And we would need to update the current cost to be equal to difference of current, not current, we just use start index. And then otherwise, it is possible to be at the current gas station, and we need to update the cost accordingly. So current cost plus equals difference of current IDX. And the one thing we're not doing is updating current index, so we can update the current index to go to the next index once we have done these two conditional statements, or one of these two conditionals. So current IDX is going to be equal to, we can just say current IDX +1 modulo n. So I think this should work. Let's give it a shot. Okay, let's submit the solution. Cool. So let's analyze the space-time complexity. So the time complexity, over here we're just looping through the list once, so that should be fine. And then here, at most, we will loop through the list twice. So overall, the time complexity would just be O of n, and then the space complexity is again O of n because we're creating this difference array. And yeah, that's the only non-constant data structure we are creating, so O of n. So that should be it. Cool.